In this video, we are going to learn how to change fractions to decimals. Let us first start with fractions with denominators which are powers of 10, such as 10, 100, and 1000. It's very easy because all we need to do is to read the fraction as is, but write it as decimal. For example, the first fraction is read as 50 hundredths. So we write it as decimal, which is 50 hundredths. Or we can simplify this also means 5 tenths. Now for number 2, it's 5 tenths. So we write it as 5 tenths. For the third one, 40 hundredths. This is how we write 40 hundredths. 6 tenths, 6 tenths. 51 hundredths, so we write it as 51 hundredths. 22 hundredths, 2 tenths, that's 2 tenths or point 0.2. 26 hundredths, 48 hundredths, then 8 tenths. We can also do that for mixed numbers. So for number 1, for number 7, we have 4 and 51 hundredths. So that is written as 4 and 51 hundredths. Then we have 8 and 913 thousandths. 8 and 913 thousandths. 1 and 1/10, 1 and 1/10. 2 and 180 thousandths, 2 and 180 thousandths. Now, how do we change fraction where the denominator is not power of 10? First example, we have 2/5. You know that 5 here is not a power of 10, but we can make it a power of 10 by multiplying the fraction by 2 over 2 or 2 halves. 2 halves has a value of 1 and any number times 1 retain its value. So it's the same as 2/5 times 1 is still 2/5, but we just make it a higher term. So here we have 2 times 2, 4. 5 times 2 is 10. So 4 tenths, it's now a power of 10. We can write it as decimal 4 tenths. For the next number, again 20 is not a power of 10. It's not yeah. So but we can also make this a power of 10. So if we multiply this by 5 fifths or 5 over 5, we will now have a denominator which is a power of 10. That's 100. 5 times 5 is 25. Now we have 25 hundredths. So we can write it already as decimal 25 hundredths. Now we have 7 over 25. 25 is not a power of 10. So how can we make it a power of 10? What number shall we multiply it by? You're right, it's 4. So we use a fraction 4/4. Remember, the value of this fraction is equal to 1. It must always be the same numerator and same denominator to have a value of 1. Now, if we multiply this, then we will have a fraction in higher terms that is equivalent to 7 over 25, and that is 28 hundredths. So these two are the same. This is just a higher term of 7 over 25. Since we have now 28 hundredths and the denominator is a power of 10, which tells you actually the place value of the decimals, hundreds. So 28 hundreds is written as 28 hundreds in decimals. Now let's do 13 over 500 or 13 500ths. What number shall we multiply with 500 so that we can make it a power of 10? We can multiply it by 2. Okay, so the fraction that we're going to use is 2 over 2. Again, we know that the value of this fraction is equal to 1. So any number times 1 is equal to the same number. So when we multiply 13 over 500 by 2 halves, we simply make it higher terms, but the value of that number retains. So 500 times 2 is 1000. And then 13 times 2 is 26. So we have here 26 thousandths, and we write it as decimal 26 thousandths. This is the thousands place. Now, there is another way of changing fraction whose denominator is not 10, 100,000 into decimal, and that is through division. We can make, we have here fraction 2 fifths, and this is the same as the expression 2 divided by 5. So if you have trouble or have problem identifying what number to multiply with the denominator to make your denominator 10, 100, or 1000, another option is to use division. We divide numerator by the denominator, and that is written this way. Sorry, it must be 5. 2 divided by 5. So 2 divided by 5 is 0 because you cannot take 5 from 2. So it's 0. Now 2 is the same as 2.0, 2.00, 2.000. Okay, so we can affix a decimal point here. And once we do that, we do it also, same alignment. We do it also with the our answer quotient. So after affixing 0, we affix after putting the decimal point, we affix a 0, and then now we can start dividing 20. So when we are dividing, you try to pretend that you don't see a decimal point. So you read it as 20 because anyway, you have already moved the decimal point in the quotient part. So 20 divided by 5 is 4. And 4 times 5 is 20. And then 20 minus 20 is 0. So once you hit a remainder 0, you can now stop. So this is a terminating decimal. Terminating means it ends. It can reach a remainder which is 0. So the equivalent of this is 4 tenths. Example. So 3/8 is the same as, this is the same as 3 divided by 8. And in order for us to solve it, we do it this way, 3 divided by 8. We know we cannot take 8 from 3, so the answer is 0. Meaning to say 3 divided by 8, you cannot take any whole number. So, and then here, we add a 0, or we affix a 0, and then we put another 0 here. So this is now read as 30. So again, when we are dividing, pretend that this decimal point here does not exist. So 30 divided by 8. How many 8 can we take from 30? 3 or 4? 3. 3 times 8 is 24. Then we subtract, it's 6. And then since we have a remainder, we continue adding more zeros. So let's add a 0 here. So we bring down that 0. 60 divided by 8, is it 5, 6, 7, 8? It's 7. 7 times 8 is 56. We subtract, we have a remainder. Since we have a remainder, we should not stop, so we continue adding more zeros here and then bring it down. 40 divided by 8 is 5. It must align, okay? 5 times 8 is 40. Now we have achieved a zero remainder, then we stop. So our answer here, 3 eighths equals 375 thousandths. Okay, 7 over 25 is the same as 7 divided by 25. So we write it this way, 7 divided by 25. We know we cannot take 25 from 7, so the answer is 0. Now we put here a decimal point because 7 means 7 points, 7.0, 7.00, 7.00. Okay, and then we affix a 0. Now we can now start dividing 70. Again, pretend that the decimal point doesn't exist. So 70 divided by 25. How many 25s can we take from 70? By the way, if we put 0 here, on top of it is also a decimal point. So again, how many 25s can we take from 70? Only 2. 2 times 25 is 50. And then we subtract, the remainder is 20. So see, remainder must be always less than your divisor. Since we have a remainder, we keep on going on. So let's affix another 0 here and then bring down 0. 200 divided by 25, how much is that? 4 for 100. So for 200, we have 8. 8 times 25 is 200. Now we have achieved a remainder which is 0. Then we stop. So the answer is 0.28 or 28 hundredths. Let's continue with the next example. 1/3. Again, this means 1 divided by 3 or 1 divided by 3. It's 0. So we affix a decimal point here, both on the dividend and the quotient. Then we put a 0 here. Now we divide 10 by 3. It's 3. 3 times 3 is 9. And then a remainder is 1. Then we again put more zeros and bring it down. 10 divided by 3 is 3. 3 times 3 is 9. So you see that even if we add more zeros here, it just keep on repeating. 3 times 3 is 9. Okay, so this means that the answer will keep on repeating. You will have 0.33333 and so on. So we can put these 3 marks to show that, or 3 dots to show that the answer keeps on repeating. So our answer here, class, is 0.333, and these 3 marks means 3 dots means it keeps going on and on. And the short way of writing this is to simply copy the digit that repeats. In this case, it's 3, and put a bar over it. They mean the same thing. Okay, so 5/6 means 5 divided by 6. So to solve, we write it this way, 5 divided by 6. Again, it's 0. We cannot take 6 from 5, so it's nothing. We put a decimal point here, and then we do it also on the quotient. And then we affix a 0. And now we divide, reading it as 50 divided by 6. How many 6's can we take from 50? Only 8. 8 times 6 is 48. And then the remainder is 2. And then we again put more zeros and bring it down. 20 divided by 6, how much is that? 3? 3. 3 times 6 is 18. So 2 again. And then we put another 0 and bring it down. 20 divided by 6 is 3. 3 times 6 is 18. You see that it will just keep on having 2 as the remainder. So that means 3 will keep on repeating. So our answer is 0.8333 and so on, which could be written also as 0.8. The digit that repeats is 3, so we write 3 and then put a bar line over it to indicate that that is the digit that is repeating.